Alright, Chapter 7, Power Roots and Radicals. Alright, keywords: nth to the root of the real number, index, simple form of radical, like radicals, radical equation, extraneous solution, composition functions, inverse relation, inverse function, radical function, standard deviation. Alright, nth root and rational exponents. You now evaluate the nth roots of the real numbers. You know that defining the volume of the cube, defining the column of the cube, the volume is equal to the surface side times 3. If you know the volume, you can find the side length. Taking the cube root, the volume of the side equals the cube root of the volume. You can extend the concept of the square roots to the cubes and other roots. Alright, we're recording again? Yeah, we're recording again. You can extend the concepts of square roots to cubes and other roots. B is the square root of A. B to the second is equal to A. B to the cube root is B to the third is equal to A. B to the fourth root is B to the A. B forward is equal to A. B to the nth root is B to the nth is equal to A. You can rewrite the nth root as nth is the A is the real number. The nth is the real number. Nth is the root of A, so that's denoted as n over the radicand. Sorry, over the radical with A and the radicand, where A is a real number and n is the index of the radical. So it's actually noted as index. The radical index n to the square root of A with the square root of A refers to the positive number nth of the A. So the radical negative n index over the square root of A refers to the negative nth root of A. Number of real nth roots. If the nth can be an integer greater than 1, and let A be a real number, the index nth is odd, and A is a real number, the number of nth roots is 1. If the nth root is greater than, with a is greater than 0, the number of nth roots is 2. If the nth root is even and the A is 0, then the number of real nth roots is 1, which would be 0. If the nth root of is even and A is less than 0, there are no real nth roots, so there's no real root. Solve an equation involve x to the nth root, the x to the nth, isolate with the power of one side of the equation, and take the nth root of each side. Rational exponents. You don't have to use radicals to write an nth root of A. You can write it in nth root of A using fractions or exponents. Note that the denominator of each rational exponent is equal to the index of the radical. The square root of 3 is equal to 3 to the power of 1.5. The index, the nth third, 3 to the square root of 7 is 7 to 1 to the third. And the square root of A is equal to 1 to the square of 1 over nth. Radical exponents. You can use fraction to exponent right combinations of the power. So you have 3 to the square root of 2 to the fourth would be 2 to the third, 2 to the third times 4, or 2 to the 4 thirds. 5 to the nth root of 9 times the 7th would be n to the n to 1/5 times 7, or n to the 7/5. Rational exponents: let a1 to the nth be the nth root of a at a is greater than 0 and is not equal to 1. Let m be positive the integer m a to the m over nth is equal to a over a to the nth times m, or nth over the square root of a to the mth. A to the negative m over a to the negative m over n equals a to 1 over a to the m, or 1 to a to 1 mth, or 1m, or 1 to the, or equal to 1 to the nth of the square root of a to the m. Properties of rational exponents. Goal: use the property of the radical rational exponents. You learn the power of the product and power of quotient properties in exponents 6.1. These properties can also be of the radicals. The nth power, the nth of the square root of a and b is equal to the nth of a square root of a times the nth square root of b. Quotient property: the nth square root of a over b is equal to the nth square root of a over the nth square root of b. Simplifying radicals. Radicals with index is in simplest form with no perfect n powers is in the radicand. There's no radicals in any denominators. To write a radical in simplest form, apply the properties of the radical, removing any perfect nth other than rationalizing any denominators. Property of rational exponents. You study with the property of integers exponents less than 6.1. The properties are true for the rational exponents. Property of the rational exponents: a and b are positive real numbers. L and m are rational numbers. A to the mth times a to the nth is a plus m. A times m to the nth is a to m times the m is a to m times n. A b to the mth is equal to a m. A to the mth, b to the mth, a to the negative mth is equal to 1 over to a to the mth, or a is when a is not equal to 0. A to the m is over a to the mth, n is equal to a to the m minus n. A is not equal to 0. A over b to the mth is equal to a to the m over b to the m, or b is not equal to 0. Like radicals, two radicals like radicals have the same index, same radicand. For example, 3 of the nth, the 3 is the cube root of 3, or the cube root of the square root of 2, and 4 to the cube root of square 2. They add some of the attractions to add and subtract radicals using distributive property. Simplifying verifying variable expressions. You can apply product property of the radical expression involving variable value of the variable is negative. You may need to use absolute value to find the nth root. Nth to the x root of n. X is when n is odd, and n to the x nth is the absolute value when x is the nth is even. Absolute value is needed. Need not all variables assume to be positive. In this lesson, assume that all variables are positive. Alright, 7.3, radical equations. Radical equation is an equation that contains a radical variable in radicand. For example, square root of x plus 5 is 5. The radical equation. Solve the radical equation following steps below. Step 1, isolate the radical on one side of the equation is necessary. 2, raise each side of the equation, same power, eliminate the radicals. Step 3, solve the resulting equation using techniques learned in previous chapters. 4, check the solution. Equations of two radicals. To solve the equation with the two radicals, first rewrite the equation from each side and has only one radical. Then raise each side of the equation the same power. Extraneous solutions. Raising each side of the equation to the same power can lead to solutions that do not make original equation true. An apparent solution does not make original equation true is called an extraneous solution. You must check apparent solutions in the original equation. Any solution that does not satisfy the original equation is extraneous. Rational exponents. When the equation contains a power with a rational exponent, you solve the equation with the same way you would solve the radical equation. Isolate the power on one side of the equation, then raise each side of the equation to a reciprocal of the rational exponent, solving for the variable. 7.4. Occupy functional operations and composition of functions. In Chapter 6, we learn how to add, subtract, multiply, divide polynomial functions. The operation can be divided in the type of the followings as well. Operation of functions. Let function fx and gx are two. By any two functions can add, subtract, multiply, add function fx and gx from the form to form a new function hx. Addition: hx is plus fx plus gx, subtraction ax plus fx minus gx, multiplication fx plus gx equals 8x, division 8x over fx over gx, or gx is not equal to 0. The domain of h consists of x values that are domains of both f and g. When h involves division, the domain does not include x values which are denominators equal to 0. Composition functions. Another operation can be performed in two function composition function. You can perform the composition function f function with a function g, replacing each variable of function f with an expression function g. Composition of function f with g is written as f g f parenthesis g parentheses x. For letting fx equal to 2x and gx x 5x plus 3, we have the composition of f with g, so it would be 2 5x3, 10x3 composition. GFX 2x plus 2x plus 3, 10x plus 3. Note that fgx does not mean something as gfx. As with subtraction division functions, you need to be order functions when they are composed, and generally with a function gx, composition functions of fgx is not equal to g function fx. Composition function. The composition of a function f and with a function g is the h is equal to fgx. The domain h is the set of all x values where x is the domain, and g and gx is the domain of f. Seven 5 inverse functions. Lesson 2.1. You learn the goal. Find the inverse linear and nonlinear functions. In lesson 2.1, you learn relation pairing input and output values given the relation. Inverse relation switches input and output values over the domain, and inverse relation over the range of the original relation, although the inverse relation of the domain is an inverse relation. So input original and negative 2, 1, 0, 1, 2 have become now the outputs of y, and the outputs of y, negative 4, negative 2, 0, 2, 4, have become the inputs of x. With the graph of the inverse relation of the reflection of the graph of the original relation, the line of the reflection is y equals x, and both original relation and the inverse relation are functions that are two functions called the inverse function. The inverse function f and g are inverse functions. F to the function of g, f and g function of x is equal to x, g is function of f, x is equal to x. Inverse of f can be denoted as f to the negative first 1, which reads as f inverse. Finding inverse functions, you can find an inverse function following these steps. Replace a function fx with y and a function written using the function notation, switching x and y, solving for y. Horizontal line test. In Chapter 2, you learn a relation function with a no vertical line test enters the graph more than once. You can use the horizontal line test instead of the inverse function also as a function. The horizontal line intersects graph of the function if f more than once, so then if the f inverse of f is also a function. Consider, for example, the inverse of f is a function and there's no horizontal line intersects the graph of the f more than once. The inverse g is not a function if the horizontal line intersects the graph of g more than once. Restricted domains. In the following example of restriction domain, restrictions placed on the domain function f. Alright, 7.6, graphing square root, cube root functions. The square root of function y is equal to the square root of x. Example of radical function. A radical function contains a radical and a variable in its radicand. the function y to the cubed square root of 4, the y to the cube root of 4x is equal, and y to the cube root, y to the square root of x plus 1 are also radicand functions. Graph of the square root of function y is equal to a times the square root of x is where a is greater than 0. The cube root functionary y is equal to a to the cube root of x where a is greater than 0. Square root function show the domain of y or equals a times the square root of x is where x is greater than equal to 0. The range y is greater than or equal to 0 where a is greater than 0. And the cube root function show the domain and range of the y, a times the cube root of the x are all real numbers. Radical functions in the real world. When you use radical functions in the modern real world, you sometimes restrict the domain values that make sense for the situation. Alright, 7.7, the standard deviation. In lesson 1.7, we analyze a set of data with applying the measure of central tendency, mean, median, and mode, measures dispersion and range. Another measuring the dispersion of the standard deviation. Standard deviation describes the typical difference of the deviation between mean and any data value set. Standard deviation of the data set x1 to x2 to the x to the n follows these steps. Find the mean of the data set x bar, and to find the standard deviation of as sigma as a sigma. So the sigma is equal to the square root of x minus x bar squared plus x to x2 minus x bar squared to the x to the nth minus x bar squared over the nth. Alright, compare data sets. The standard deviation data set can tell you whether the data value for the spread out of the closer than. Standard A deviation of 14 means 50. Standard deviation of small of the data values together. Standard step B. Standard deviation of 37. The means of 50. Standard deviation is larger data values spread apart. Using technology, using graph calculator, find standard deviation of the data set. Chapter 7, summaries, review, and to the root of a real number, index, simple form of radical, like radicals, radical equation, extraneous solution, composition of functions, inverse relations, inverse function, radical function, standard deviation. Chapter 8, exponential logarithmic functions.